ver, içeri ver.
Welcome to the Piping Engineering YouTube channel. In today's video, we will learn simple formulas to easily calculate the center-to-center elbow length, determine elbow degree angles, and find the true length of pipes in a double-rolled pipeline. First of all, thank you to all our members and subscribers for your amazing support. If you'd like to support our educational mission, subscribe or check out our membership packages linked in the description below. Alright, let's dive into today's lesson. To determine the length of a pipe section between two elbows in a pipeline, we will follow these steps. Calculate the overall length and the center-to-center distance between the two elbows. Determine the angle, length of the elbows, and their takeoff dimensions. Finally, subtract the elbow lengths and welding gaps from the overall length. The formula can be expressed as pipe length equals overall length, 2 times elbow length, 2x caps for welding. We will perform all these calculations step by step on this 8-inch pipeline section. Let's denote the overall length or the center-to-center distance between the elbows as L. In our previous videos, we explained that the double rolling part of the pipeline is easier to understand when visualized within a right-angled parallelogram. As you can see, the 8-inch pipeline extends southwards. At the top right corner of the parallelogram, the pipeline first descends by 441 mm, then continues southwards for 978 mm before turning eastwards for 444 mm. Finally, at the bottom left corner of the parallelogram the pipeline again continues southwards. During the double rolling of a pipeline, 2 right-angle triangles are formed using dashed lines. We will use these triangles to calculate the overall length, elbow length, and true pipe length. Let's first label the hypotenuse of the horizontal dashed line right-angle triangle with the letter H and then determine its length. To find this hypotenuse, we will use the Pythagorean theorem. According to the Pythagorean theorem, the square of the hypotenuse h will be equal to the sum of the squares of 978 and 444. Using a calculator and find that the square of 978 will equal 956484. And the square of 444 will equal 197136. So, we continue to calculate that h squared will equal 956,484 plus 197136. Using the calculator again, 956484 plus 197136 will equal 1153,620. So, we find that h squared will equals 1153,620. Again, using a calculator, h will equal the square root of 1153,620. It will equal approximately 1074. So, after performing the calculations, we found that the length of the hypotenuse of the horizontal dashed line right-angle triangle is 1074 mm. The hypotenuse of the horizontal right triangle also serves as the perpendicular side of the vertical right triangle. Now, let's label the hypotenuse of the vertical dashed line right-angle triangle with the letter L and calculate its length. To find this hypotenuse, we will use the Pythagorean theorem again. According to the Pythagorean theorem, the square of the hypotenuse L will be equal to the sum of the squares of 441 and 1074. Using a calculator, we calculate that the square of 441 will equal 194481. And the square of 1074 will equal 1153,476. So, we continue to calculate that L squared will equal 194,481 plus 1153,476. Using the calculator again, 194481 plus 1153,476 will equal 1347957. So, we find that L squared equals 1347957. Again, using a calculator, L will equal the square root of 1347957, which is approximately 1161. The hypotenuse of the vertical right triangle also serves as the overall length, or the center-to-center distance between the two elbows. So, after our calculation, we found that the overall length or the center-to-center distance between the two elbows is 1161 mm. Now calculate the elbow degree for these dimensions on this pipeline. To find the elbow degree, we will use the trigonometric function. So, if we denote this angle as A, then A degrees will be equal to the arctangent of 441 divided by 1074. Using a scientific calculator, the arctangent of 441 divided by 1074 will equal approximately 22 degrees. So, we calculated and found that the cutting angle of these elbows is 22 degrees on the 8-inch pipeline. Now we should find the length of the 8-inch 22-degree elbows. We will use this formula to find the length of the elbow, which we have prepared and shared in many videos previously. I will also include the links to those videos in the description below. The elbow length will equal the tangent of elbow angle divided by 2 times 38.1 times the nominal pipe size NPS of the elbow. Now we will substitute our elbow angle and nominal pipe size information into this formula. So, our elbow length will equal the tangent of 22 divided by 2 multiplied 38.1 multiplied by 8. Using a scientific calculator, the tangent of 22 divided by 2 multiplied 38.1 multiplied by 8 will equal approximately 59 millimeters. So, we calculated and found that the length of the 8-inch 22-degree elbow is 59 millimeters in this pipeline. Also, from our other videos, we learned that during fit-up a small gap is required for welding. It should be approximately 3 to 4 millimeters. Now I will show you a small fragment in practice demonstrating how to set the fit-up gap for welding. Please watch it so you can get an idea of the gap in the fit-up. This gap is necessary for a good root weld. Now let's find out true length of the pipe length. Now, we will substitute our overall length, elbow lengths, and welding gap information into above formula. Pipe length equal the overall length 1161 minus 2 times the elbow length 59 and minus 2 times 3 for the caps for welding. Using a calculator, 1161 minus 2 multiplied by 59 minus 2 multiplied by 3 will equals 1037. So, we calculated and found that the red-colored pipe length between the two elbows is 1037 millimeters. By using this method, you can easily calculate the pipe lengths and elbow angles of pipe sections for your desired pipelines. This educational video ends here. Feel free to share your thoughts about the video in the comments section. By joining our channel, you can support us and enjoy exclusive features. If you enjoyed the video, please like and subscribe to our channel. We would like to thank everyone who commented on or liked our work to show their appreciation. Thank you for watching and see you in the next video.
Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. You can also benefit from some private benefits by membership to our channel. Let's starting our piping tutorial video. In this video, we will learn what is piping slope and why is it required, how to calculate pipe slope. The standard slope of a pipe is 1/4 inch to 3 inches. Pipes must slope downhill to drain correctly. Proper slope calculation is essential for draining. If not sloped enough, the pipe won't drain. If sloped too much, it won't drain solids. As you can see, this is piping isometric drawing with some slopes and different elevations. In the piping isometric drawings, the slopes are showing with this symbol. In this drawing, slope of the incline is expressed as a ratio of 1 to 100, meaning that for every 1 unit of vertical elevation there are 100 units for horizontal distance. 1% slope denotes 1 unit rise or fall for every 100 units horizontal length or distance. In this case, drain should be down by 1 foot for every 100 length. Let's calculate with slope ration in this example. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 1500 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 1500 ratio. Continue. X equals 1500 to 100 ratio. Continue the calculation and found x equals 15 millimeters. This means that the 1500 millimeter long pipeline falls 15 millimeters down at the other end with a slope of 1 to 100 ratio. It is also possible to calculate the slopes in the pipelines with the elevations showing at the turns in the pipeline. In this piping isometric drawing, the initial height of the pipeline elevation is 19,500 millimeters, and the height of the pipeline at the second turn with a slope of 1:100 elevation is 19,485 millimeters. where the initial height 19,500 mm minus the second height 19,485 mm equals will be 15 mm. With this method we can calculate the difference of the levels in the second and third rotations. Second elevation 19,485 mm minus third elevation will be 19,477 mm equals 8 mm. Let's calculate slope ration now. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 800 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 800 ratio. Here x equals 800 to 100 ratio. Continue the calculation and found x equals 8 mm. With this method we can calculate the difference of the levels in the fourth and fifth rotations. Fourth elevation 19,077 mm minus fifth elevation 19,055 equals will be 22 mm. Let's calculate with slope ration now. In this pipe isometric drawing, the slope of the slope at a horizontal distance of 2,200 is expressed as a ratio of 1 to 100. 1 to 100 ratio equals x 2200 ratio. Here x equals 2200 to 100 ratio. Continue the calculation and found x equals 22 mm. When you want to calculate a slope, you can use both method on the piping drawing. This education video is finishing here. Your comments about video you can write in the comments section. By becoming a member of our channel, you can support our channel and benefit from some features. I would like to express my deep gratitude to our viewers who already have member to our channel. If you liked the video, don't forget to subscribe to our channel. I would like to express my thanks in advance to our viewers who write comments and likes. Thank you for watching. See you on next video. Take care.
Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. You can also benefit from some private benefits by membership to our channel. In this video we will show you step by step how to calculate the weight of the carbon steel pipes with easy method. Let's start our education video. The formula for finding the weight of the pipe is as follows. Weight equals volume multiply the density of the material of the pipe. In this formula, the density of the material is taken from the density chart of the materials. We have to calculate the volume ourselves. For calculate the volume we will use this formula. The volume is equals P multiply, in brackets the squared of outside diameter minus the squared inside diameter, divided by 4, multiply length of pipe. This formula belong for all pipe sizes. We will be explaining the calculations in this video on a 10-inch and 16-inch pipe examples. Let's calculate the weight of a 10-inch pipe with a thickness of 80 schedule and a length of 2 meters. To estimating the volume of the pipe piece, let's look at the wall thickness of a 10-inch schedule 80 pipe from the steel pipe dimension chart. This is the steel pipe dimension chart. The nominal pipe size is shown in the first column. The outside diameter of pipes is shown in the second column. The nominal wall thickness schedule is shown in this last column. We will look row shown nominal pipe size 10 inch. The outside diameter of the 10-inch pipe is shown approximately 273 mm and wall thickness 80 schedule is shown as 15.09 mm. Now we can calculate inside diameter of this 10-inch pipe. The inside diameter will be equals the outside diameter 273 minus 2 times wall thickness 15.09. Using the calculator, we find that the 273 minus 2 times 15.09 will be equals approximately 243. So, we calculated and found that the inside diameter of the 10-inch schedule 80 pipe in our example will be equals 243 millimeters. These dimensions should be converted to meters, because in the density charts of ferrous metals they use meters. Then, outside diameter of 10-inch pipe in our example 0.273 meters and inside diameters will be 0.243 meters. We also know that the length of the pipe is 2 meters. Now let's write this information we found in the volume calculation formula. The volume 10-inch pipe in our example will be equals P multiply in brackets the squared 0.273 minus the squared 0.243 divided by 4 multiply 2 meters. Using the calculator, we find that the 3.14 multiply in brackets the squared 0.273 minus the squared 0.243 divided by 4 multiply 2 will be equals 0.0243. So, we calculated and found that the volume of the 10-inch pipe in our example will be equals 0.0243 cube meters. Now let's look at the chart showing the density of iron material. In this chart, iron steel density 7,850 kg/cube meters is shown. Now let's write this information we found in the weight calculation formula. Weight equals volume 0.0243 cube meters multiply the density of the material 7,850 kg/cube meters of the pipe. Using the calculator, we find that the 0.0243 multiply 7850 will be equals 190. So, we calculated and found that the weight of the 10-inch pipe in our example will be equals 190 kilograms. Now let's calculate the weight of a 16-inch iron pipe with a wall thickness of 160 and a length of 5 meters. Since I know some of the calculations now, I won't repeat them and will move quickly. We will look row shown nominal pipe size 16-inch in the pipe size chart. From the pipe size chart, we find that the outer diameter of the 16-inch Schedule 160 pipe is 406.4 mm and wall thickness is 40.49 mm. Then, the inside diameter will be equals the outside diameter 406.4 minus 2 times wall thickness 40.49. Using the calculator, we find that the 406.4 minus 2 times 40.49 will be equals approximately 325. So, we calculated and found that the inside diameter of the 16-inch Schedule 160 pipe in our example will be equals 325 mm. These dimensions should be converted to meters also. Then, outside diameter of 16-inch pipe in our example 0.406 meters and inside diameters will be 0.325 meters. We also know that the length of the pipe is 5 meters. Now let's write this information we found in the volume calculation formula. The volume 16-inch pipe in our example will be equals 3.14 multiply in brackets the squared 0.406 minus the squared 0.325 divided by 4 multiply 5 meters. Using the calculator, we find that the 3.14 multiply in brackets the squared 0.406 minus the squared 0.325 divided by 4 multiplied 2 will be equals 0.2324. So, we calculated and found that the volume of the 16-inch pipe in our example will be equals 0.2324 cube meters. We already knew iron steel density is 7,850 kg/cube meters. Now let's write this information in the weight calculation formula. Weight equals volume 0.2324 cube meters multiply the density of the material 7,850 kg/cube meters of the pipe. Using the calculator, we find that the 0.2324 multiply 7850 will be equals 1824. So, we calculated and found that the weight of the 16-inch Schedule 160 pipe in our example will be equals 1824 kilograms. Summarizing what we learned in this video, we can also use this formula to find the weight of the pipe. Weight is equal to P multiply in brackets the squared of outside diameter minus the squared inside diameter, divided by 4, multiply length of pipe and multiply density of pipe material. By using this method, you can easily calculate weight pipe pieces in the any pipe drawings. This education video is finishing here. Your comments about video you can write in the comments section. By becoming a member of our channel, you can support our channel and benefit from some features. I would like to express my deep gratitude to our viewers who already have member to our channel. If you liked the video, don't forget to subscribe to our channel. I would like to express my thanks in advance to our viewers who write comments and likes. Thank you for watching. See you on next video. Take care. Welcome to our Piping Engineering YouTube channel. We continue our free piping education videos in this channel. Before starting this video, please subscribe to our education YouTube channel to watch more piping engineering videos. In this video we will show step by step how to calculate the distance between the centers of the elbows in the pipeline, the cut elbows length and the length of the pipe piece between these elbows in the 3D model view of pipeline. Let's starting pipe tutorial video. We will perform the calculations in this video on a 5-inch 3D model view of pipeline. To find the length of the yellow color pipe piece between these two elbows, first we must calculate the distance between the centers of the elbows. On next stage we need to find the lengths of the 5-inch cut elbows, and finally from the total length between the centers of the elbows we will subtract the lengths of the cut elbows and the gaps for welding. Let's go step by step. As you can see, 5-inch pipeline comes first horizontal then vertical up with 420 mm and then continue horizontally again. Right triangle is formed with dashed lines after the pipeline rises vertically obliquely 420 mm. The hypotenuse of this right angle triangle is the distance between the elbows in the pipeline. Let's mark the hypotenuse of this vertical right angle triangle with big letter H. Now let's begin to find the hypotenuse of the vertical right angle triangle. We will use the Pythagorean theorem formula in such cases to calculating the hypotenuse of this right angle triangle. According to the Pythagorean theorem formula, hypotenuse h squared will be equals 420 squared plus 770 squared. Continue to calculate the h squared will be equals 769,300. We continue to calculate to find h more easily. H will be equal to 769,300 under the root. At last we will use scientific or phone calculator and found h will be equals to 877 mm. So, the overall length between the centers of the butt weld elbows is 877 mm. If we subtract the lengths of the cut elbows and the gaps for welding from this total length, we can find the length of the yellow color pipe section. Now let's mark the cut angle of the elbow with A and calculate this angle. In such cases, we will use the trigonometric function formula to calculate the acute angle of this right triangle or the intercept angle of the elbow. According to the trigonometric function, tangents A degrees will be equals 420 divided by 770. We find that 420 divided by 770 equals 0.5454 using a scientific calculator. Using the calculator we find that arctangents 0.5454 will be equal to 28.6 degree. So we calculated and found that the cutting angle of the following elbow is 28.6 degrees. 28.6 degree is one of the acute angle of the right angle triangle. Now let's start calculating the cutting angle of the second elbow on the top. Let's go step by step. Since the pipeline moves in the same plane, let's complete this right triangle into a rectangle.